For the third consecutive year, students enrolled in Ulster BOCES Custom Robotics Design and Manufacturing and New Vision's Advanced Robotics and Engineering classes have been working with NASA's Hunch program to manufacture stowage lockers that will be sent to the International Space Station.
You know, a lot of people would think, what are you doing trusting high school students to make flight hardware, right? I mean, it seems like a big risk. The reality is that with the technology increase, with manufacturing, especially using things like Mastercam to draw it up and then to figure out, have it spit out the G-code, and teaching the student how to do a setup and things like this has made it to where, yes, less skilled people can actually perform this level, but or it takes less training to get them there.
Many of these high school students who are barely old enough to drive will soon have parts that they machined sent 220 miles into orbit.
Last year, the students signed a locker, and it is going up this 15th of February. It's flying on a SpaceX 10, and it is going to be taking stowage items to the International Space Station.
Students from various schools from across the country were charged with manufacturing several different parts of the 56-part locker assembly.
For this NASA project, I started making one part out of aluminum. They call it an actuator. Not sure what that means, but it's part of a bigger piece where I think it spins to close out the door.
NASA officials paid a visit to Ulster BOCES to let students who worked on the project sign their names to the lockers.
What's very interesting is that when you look at all the hardware that's gone into space, that less than 0.5% of those that have either built it, drawn it, or designed it ever got to sign a piece of hardware. So this is a very unique opportunity.
For some, this once-in-a-lifetime opportunity made signing their names a little nerve-wracking.
Really nervous. I forgot how to sign my name.
The names were the final touches on the aluminum lockers designed to hold up to 70 pounds and withstand 3 times the forces of gravity.
There's major precision here. All of our hardware has a tolerance of 5/1000ths of an inch, which the average hair is 3/1000ths of an inch. So you can be a little over a hair off and it'd still be good.
Students felt very honored they were able to contribute to something that will eventually head out into space, all while still in high school.
I mean, it sounds really, really cool. I mean, my sister, I told her I'm signing this today, and she's like, what? That's cool. I mean, I did something similar, I guess. I just wrote a paper on NASA. It's not the same, hon.
No.
Not the same.
I think it's great. A lot of people have technology classes where they sit down with a book and they learn how to make things out of wood, or they make it out of cubes. But the way that BOCES runs this program is that we do things like a solar car. We don't learn how to use a machine and make a pretty looking, I don't know, gizmo, where you make parts for a car that we're going to drive across the country, or we make pieces for NASA that go to the International Space Station. It's just a great way to do it, in my opinion.